Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Good morning, students. And our next topic in fourth unit is protection against overvoltage. That is, how can we protect or how do we protect our transmission line or power system or substations against overvoltage. So as we discussed earlier, overvoltage can be caused by several surges. It may be due to internal surges or external surges. Internal in the sense like switching surges due to on and off operation and capacitor banking operation and so on. And external causes in the sense it means lightning and etc. So normally faults are classified into two types, which is symmetrical and unsymmetrical, and three-phase fault comes under symmetrical fault. And unsymmetrical fault is further classified into three types, so which is line to ground fault, double line fault, or double line to ground fault. So what are the precautions taken to protect our power system or transmission line against this overvoltage? So there are several methods which have been implemented to protect this transmission line. So the following is given here. So you can see that using ground wire, ground rods, counter-poise wires, and other protective devices like arresters, that is surge arrestor or lightning arrestor, and etc. Even some other devices also can be used. So the very first one is ground wires. So let's discuss in detail. So ground wire is very simple and is very common, which you might have been seen even in our surrounding, that it's normally a conductor which is almost equivalent or which is almost similar to that of the transmission line. So even you can see this in towers outside your home. So you can see 4 to 5 lines, so which we call it as RYB, that is the overhead transmission line. So at the topmost part of the tower, that is our tower or pole, there will be a topmost line which we call it as ground wire or neutral wire, that is ground line or neutral line. Actually, it is placed at the topmost part of the tower and it runs parallel to that of the transmission lines. So it's also a conductor and it is almost equally spaced, similar, that is the spacing is also equal and is regularly spaced, similar to that of the transmission line. Actually, this ground wire is placed at the topmost part in order to overcome the direct stroke. Direct stroke in the sense lightning, which we have learned. There are two types of lightning, direct stroke and indirect stroke. Direct means when lightning hits directly towards the line, that is direct, when it hits directly the transmission line, we call it as direct lightning stroke, right? So to safeguard the transmission line from direct stroke, we are using ground wires here. So what are the considerations which should be taken into our mind during the selection process of ground wire is, so while choosing a ground wire, you have to give more importance in mechanical consideration rather than electrical, because mechanical strength is very important, such as like stability, reliability and etc. So normally the ground wire should have a very high strength, also it should be non-corrosive, and moreover the ground resistance also should not be in a very high value. It should be according to the prescribed value. Also the insulation should be very proper, that is proper insulation should be provided, and the design of the line also should be up to the expected or the prescribed level. And the next one is shielding angle or protection angle. So this is nothing but the angle between the vertical line drawn to the vertical of tower and the line through the ground wire and the shielded conductor. So the protection angle differs from a particular ground wire and tower to tower. So this has a particular value, that is the protection angle has a particular value only which at a particular or prescribed value the fault can be overcome, or the equipment or the transmission line can be protected. And the next one is for effective protection of this transmission line using ground wire, the major consideration is height and the shielding angle or the protection angle. So the protection angle should be approximately equal to 30 degree, and the material used for making or manufacturing of the ground wire is galvanized stranded steel conductor. Galvanized stranded steel conductor. So up to 110 kilovolt and even above 110 kilovolt, this ground wire can be used for protection purposes. Moreover, it gives protection against traveling waves too. Okay, and so these all about ground wires. And the second one is ground rods, that is using ground rods. Actually, ground rods in the sense, these are rods which are buried into the surface, that is buried in the earth, and this mainly depends upon the tower footing resistance. Actually, in order to reduce the tower footing resistance, we are using this ground rods. Tower footing resistance means there will be a particular resistance at the bottom position or at the foot of the tower. So unless and until it is maintained, or else unless and until this tower footing resistance is low, the over voltage cannot be grounded. So if the tower footing resistance is high, it may result in some other explosion, or it may damage the insulation also. That is, the tower footing resistance should be very low as possible. So if it is low, it results in very less voltage stress across the insulator. Moreover, it should be buried at 3 meter into the ground. That is, it should be buried at a length of 3 meter into the ground. And also the tower footing resistance can be varied by varying the spacing of the rod and varying the number of rods, also the depth, that is the depth in which we bury. So the tower footing resistance should be 20 ohm for extra high voltage line, and it should be 10 ohm for high voltage line. So if it is beyond this prescribed level, and definitely that is really it is impossible to ground the over voltage which occurred due to lightning or some other surges or something else. And moreover, especially this tower footing resistance depends on two properties. That is, one is the resistivity of the soil. So based on the resistivity of the soil, that is the tower footing resistance can vary, and also based on the type of electrode which we use at the ground rod or at the resistance, that is the type of electrode configuration also, this tower footing resistance can vary. Okay, and here the material used for tower footing resistance is galvanized iron or copper bearing steel. So this is all about ground rods, that is which mainly depends upon the tower footing resistance. And the very third one is counter-poise wires, that is using counter-poise wires. So this is nothing but a kind of a wire which is buried into the ground at the depth of 0.1 to 1 meter, that is up to 0.5 to 1 meter depth we have to bury this counter-poise wire. So it is almost similar, parallel to the parallel to that of the transmission line conductor, which is connected at the tower legs. So normally transmission line overhead line which will be running at the top and top of the tower, and below the ground of the tower, that is at the tower legs or into the earth, this counterpoise wire will be running in parallel, which is similar to that of the transmission line. So the length of the wire can be up to about 50 to 100 meter long. That is, the length of the wire is 50 to 100 meter. And even you can see the arrangement in the figure given here, that is radial continuous, and this is what the arrangement in which we can so prefer based on the resistivity or based upon the THD calculation of a particular area. So here what happens, so when the lightning stroke incident on the tower, or when the lightning hits the tower, as we all know, a very high voltage is runs across the transmission line, right? That is, a very high voltage is implemented on the line. That is when the lightning stroke hits that line. So what happens here is the very high voltage which occurs due to the lightning is discharged discharged towards the ground through the tower. That is, the over voltage, that is the excess voltage which arises due to the lightning, is discharged through the tower towards the ground through this counterpoise wire. So for proper operation of this counterpoise wire, the resistance of the counterpoise wire should be very, very less. So if the resistance is very high, the over voltage cannot be grounded. So therefore, the over voltage, so in order to ground the over voltage, the resistance of the counterpoise wire should be very, very less. That is, it should be less than that of the surge impedance or surge resistance. Okay. Now actually most probably it is used for the protection of line to ground fault. So that the tower footing resistance also should be very, very low. So here the counterpoise wires are made up of or manufactured by galvanized steel wires. So it's also mainly used in power system protection, that's power system based protection against traveling waves, which is also caused by lightning. Okay, so the major one, which is known as surge arrestor or lightning arrestor, is used which is used for the protection against lightning. So we all know that even we will be using it in our household to protect the household applications, equipments also, which may be used in tall buildings. So actually there are certain requirements for the lightning arrestor which we should consider during the selection process. So actually the lightning arrestor should not pass any current to the system component even during abnormal condition. During normal condition or abnormal condition, the lightning arrestor should not pass any current or over voltage to the equipment which is to be safeguarded. And then during abnormal condition, it should not break down. Moreover, it should have a very high stability. Also, it should not pass any surge current. Moreover, the surge current should not damage the lightning arrestor too. Only then the equipment can be safeguarded. Okay, and then it should also safeguard the equipment from power frequency and other surge current which arises due to even other switching surges operations also. And the very next one is shunt protector devices. That is, there are so many types of lightning arresters which we call it as rod gap, horn gap, expulsion type, wall type, etc. So today let's deeply discuss about the first two types, which is called as rod gap and the expulsion type. So rod gap, in the sense, you can see the figure, you can find two rods, right? So this is the figure. So you can see the arrangement of rod gap arrestor. So this is the way in which the rod gap arrestor is arranged. So you can see two rods there, and also you can see a gap in between the two rods. Actually what happens is, when over voltage hits the line or some other thing in the power system, what happens is the over voltage reaches the rods, and which causes a flux over there. Due to the flux, a spark or an arc is created between the two rods. Actually, this arc extinguishes by itself when the over voltage is being stopped. Okay, so when the over voltage reaches the rod, due to the production of flux, an arc is created between the two rods, and this arc extinguishes once the over voltage is stopped. So by the way, the equipment can be protected. So the distance between the gap should not be less than 1/3. The distance between the gap and the insulator should not be less than 1/3 of the gap length. That is the gap length, in the sense, the gap between the two rods. So if this distance is not considered, what happens is, due to the production of arc, the insulator may get damaged. Why? Because due to the production of arc, there may be a huge production of heat, and due to that, the insulator may be get damaged, or the insulator may get exploded. So the advantages are it's very simple in construction and cheap, and also the following the advantages, you can see the disadvantages there. So what are the disadvantages? As I already said, the gap length is very important to safeguard the insulator. So it is used in backup protection. And then the limitations. So limitations of rod gap is it's not capable of preventing the power frequency current, so discharges takes place, and moreover, as I said in the earlier, more heat is produced, and sometimes it can damage even the material which we want to safeguard. Also it may damage the insulator too. And the last topic is expulsion type lightning arrestor, so which we also called as protector tube. So it's also a device which is used to protect an equipment or a transmission line against lightning. So the major advantage or the reason why this expulsion type lightning arrestor is preferred the most is nothing other than the arc extinguishing capability. That is the very good speciality of this lightning arrestor is the arc produced can be extinguished by itself. That is, when the overvoltage is stopped, the arc extinguishes by itself. That is, no other external source is required for the extinguishment of the arc. So it provides a very low impedance path for the flow of current. If the impedance path, that is, if the impedance in the impedance path is very high, or else if the resistance in the ground is very high, definitely the over voltage cannot be grounded. So in order to overcome this, it provides a low impedance path. So you can see the arrangement here. So you can see the upper electrode, which consists of a series gap. So this upper electrode will be connected to the equipment, and the other end of the electrode, that is the other end of the electrode, which means ground electrode, is grounded or it is connected to the neutral. So you can see the series gap here. So you can see a point where nearby the series gap, so that is connected to the equipment, and the arc is created in between the gap. That is, when over voltage or when high voltage enters or reaches due to the lightning, an arc is produced, and this arc also have the capability of extinguishing by itself. So that only because of this expulsion type lightning arrestor is preferred to be the most. So it is used in used to protect transmission line insulators, also to protect the distribution transformers. So the major advantages are it's very cheap, and also it is used to protect a rural transformer, which that is normally people use wall type arresters, but wall type arresters are very expensive nowadays. So in order to overcome this drawback, to protect the small rural transformer, that is small type of transformer, we can use this expulsion type lightning arrestor. So that's all for today's class, and thank you.